My name is Dagondo Mpande, and I'm here today with my colleagues Kumbugan Mwambembe and Tatiana Jingen. So we're final year students here at Mopas. I'm studying computer engineering. He's studying telecommunications engineering, and she's studying computer engineering, same as me. So back in months ago, back in February and March, we visited Blantyre Water Board, so that we wanted to understand what's the problem with the current meters that have been deployed right now and the ones that are being in use right now. So when we had visited them, they had told us that the current prepaid water meters that are being used, they run on batteries. So the challenges that they were meeting was inaccuracy in terms of billing and also power consumption, because the components that have been used in the meter are consuming much power. For instance, valve, the one that closes and opens the meter, draws much power. So that was reducing the lifespan of the batteries that were being used. And with that, we thought of bringing a solution of how maybe we can remove the power consumption problem by adding a power generator or something like that would be continuously producing power, so there is no issue of power consumption, to say lifespan of the batteries has been reduced. So we thought of introducing a solar that would continuously be producing power and providing power, so that it should power up the whole system. And that is what we did. And to tackle the problem of inaccuracy, we adopted the use of a Hall effect sensor, so that it accurately measures the water that's passing through the meter. So that's all about the problem. The thing that it is solving is power consumption, in terms of finding a thing that will continuously power up the meter, and also accuracy. So my colleague will take you through the stuff.
So yeah, as he mentioned, Waterboard lost about 8.3 billion within a year because of 40 prepaid water meters, which was a result of poor batteries that were in use. So we're trying to resolve that. So basically, our prepaid water meter, as you said, is powered by a solar panel, which is behind you. And the changes that we had during our project mainly was the use of the batteries that we had. So the batteries were 40 in the sense that we purchased the batteries were of low capacity. So we had a challenge powering it up. And the other challenge that we had was the valve that we were using in this case. We wanted to use a solenoid valve, but we had a challenge. We could not get one which could fit our prototype. So we used a ball valve interface with the servo motor. Yeah, so I think my colleague will just give you a bit of how this thing works.
Okay, so for our solar prepaid meter, we also created an application, which is a customer user interface. So I'm just going to take you through how the solar prepaid water meter operates. So this is our customer user interface. You can see it. So what you do is that you connect it to the meter. As you can see, it works on Bluetooth connection. And then you have this part where you have to enter your token. So I'm just going to enter the token. And done. Once I add it, it tells you that token accepted and 50 liters added to your balance. So if you can see here, it also shows you the balance that is there. Yeah. Okay, so we'll have to open the tab over there so that you can see it in operation and the water that is being consumed and the water balance.
And the other thing is it's real-time monitors the consumption of the water that is being consumed. We also back a few months ago, we also had conducted a survey asking people who have prepaid water meters installed in their places, and they had expressed an interest to say they would love to be monitoring their usage, so they should be budgeting their water usage monthly or weekly in a better way than just receiving a bill or buying in bulk and then realizing that the water has finished. So yeah, my colleague will take you through the recommendations.
Okay, so my colleague is going to open the water supply so that you can appreciate it. So after we have recharged the token, we're able to see the water flowing through the pipe. In this case, the valve is open, and as you can see on the LCD, the volume is decreasing as the water is running out through the meter. And we can also see the battery percentage via the LCD. Yeah, so basically that's what we had as for our project. We would recommend people who are interested in continuing this project to research more and implement a battery management system that will help to supply power to the meter for a longer period, and also to introduce cellular communication in the meter so that both the water board and the customer can monitor their consumption or the usage of the meter remotely from any location at any time. And yep, thank you. Basically, that's what we had for our project.